Right now, inside a crater in southern Washington state, a wall of ice is moving forward, not melting, not retreating like almost every glacier left on this planet, advancing, some years by as much as 135 feet, thickening by up to 50 feet, creeping across ground that is still warm underneath. It is called Crater Glacier, and it is the youngest glacier on Earth because the mountain that grew it did not exist in its current shape until it tore itself apart in front of live television cameras. That mountain is Mount St. Helens. And if the last time you thought about it was a photograph in a textbook, a gray cone with the top sheared off, then you are exactly the person this video is for, because the story most people carry around about this place ended in 1980. The real story never stopped. The United States Geological Survey ranks Mount St. Helens as the most dangerous volcano in the lower 48 states, ahead of Rainier, ahead of Shasta, ahead of every other mountain south of Alaska. And in the last 3 years, it has done something that made scientists sit up and start talking about it in a word usually reserved for something building toward a future event. They started calling it recharging. Here is what most people actually remember about May 18th, 1980. And it is usually just one image. A mountain that used to have a clean, symmetrical peak and then did not. What most people do not carry around is the scale of what actually happened that morning, and the scale is the whole point. At 8:32 in the morning, a magnitude 5.1 earthquake shook the mountain, and about 20 seconds later, the entire north face of Mount St. Helens let go all at once. Not a landslide the way you picture a landslide. A hillside of loose dirt sliding a few hundred feet. This was the largest landslide ever recorded on Earth. Nearly 3 cubic kilometers of rock and ice, an area of land bigger than 20,000 football fields, sliding away from the mountain at speeds well over 100 miles an hour. And because that entire flank had been holding a lid on top of pressurized magma underneath it, the instant the lid came off, the mountain did not simply erupt upward. It exploded sideways, directly into the path the landslide had just cleared. In under 3 minutes, 230 square miles of old-growth forest was flattened to the ground. Trees snapped off and laid down in the same direction, like a field of grass after a storm. The ash column climbed to 80,000 feet in the first quarter of an hour, and over the next 9 hours, measurable ash fell across 11 different states. 57 people died that morning. Among them was David Johnston, a young geologist with the United States Geological Survey, who had been monitoring the mountain from an observation post 6 miles from the summit, a post his colleagues had actually argued was too close. His last transmission, sent the instant the north face began to move, was 5 words: Vancouver. Vancouver. This is it. Also among the dead was an 83-year-old man named Harry Truman, who had run a lodge on the shore of Spirit Lake for more than 50 years and refused every single evacuation order, telling reporters the mountain would never hurt him. He was buried, along with his lodge and his cats, under hundreds of feet of debris, in the same event that physically picked Spirit Lake up out of its basin and moved it. This is not ancient history to the audience watching this. If you were alive and paying attention to the news in 1980, you remember exactly where you were when this happened. And that is exactly why almost nobody watching this video knows what has happened at this mountain since. The land itself did not recover the way anyone expected. Scientists set the entire blast zone aside as a national volcanic monument almost immediately, on purpose leaving it untouched, specifically so researchers could watch what happens when 230 square miles of forest gets wiped down to bare ground in a single morning. What they found surprised almost everyone who studied it. Gophers that had been sheltering underground survived the blast and started turning up soil within days. Wind carried in spider silk and insect larvae before a single tree seed had a chance to land. Purple lupine, a wildflower that fixes nitrogen into dead volcanic soil, spread across the pumice plain faster than any ecologist predicted, and within a decade, the so-called dead zone was quietly one of the most studied living laboratories on the planet. The observation ridge where David Johnston sent his final transmission was later renamed in his honor, and it now sits directly above a permanent monitoring station, part of a network of seismometers, GPS sensors, and webcams that watches this mountain every hour of every day, feeding data straight back to the same agency he worked for when the mountain took his life. Let's stay with the scale for one more minute, because it matters for what comes later. The United States Geological Survey scores every volcano in the country on a 24-factor threat assessment, weighing how active a volcano is, how explosive its history has been, and how many people live close enough to be in danger. Only one volcano in the entire country outranks Mount St. Helens, and it is Kilauea, which sits on its own island in the middle of the Pacific, actively erupting on a schedule most of the country will never witness in person. Every other volcano capable of threatening an American city or town, from Rainier looming over the Seattle suburbs, to Shasta in Northern California, to the volcanoes strung across Alaska, scores lower than Mount St. Helens. This is right now the single most dangerous volcano that most Americans could actually drive to in an afternoon. Keep that in mind, because in a few minutes I am going to show you exactly why scientists have been watching it more closely than they have in years. Here is why that ranking matters, and it is worth understanding the actual mechanism because it explains something that confuses a lot of people the first time they hear it. Kilauea, sitting above Mount St. Helens on that threat list, erupts constantly, sometimes for months at a stretch, and yet it rarely kills anyone because Hawaiian volcanoes sit over what geologists call a hot spot, producing thin, runny lava that flows downhill slowly enough for people to walk away from it. Mount St. Helens sits somewhere completely different, directly above a subduction zone, the same slow-motion collision of tectonic plates that built the entire chain of Cascade volcanoes running from California up through Washington. Subduction zone magma is thick, sticky, and packed with trapped gas, the geological equivalent of shaking a bottle before you open it. Instead of flowing gently downhill, it plugs its own exit, builds pressure underneath that plug for years or decades, and when it finally lets go, it does not ooze, it explodes. That is the mechanism behind every dangerous moment in this mountain's history. The same mechanism sitting underneath Rainier, underneath Shasta, and underneath the fault system this channel walked through in the Cascadia video. It is also exactly the mechanism scientists are watching for signs of, again, right now. For the 6 years after the eruption, the mountain did what a wounded volcano usually does. It built a lava dome, a slow, accumulating plug of thick, sticky rock, rising inside the crater the blast had carved out, one small eruption of lava at a time, between 1980 and 1986. Then it went quiet. Not silent, volcanoes are never truly silent, but quiet in the way that let an entire generation of Americans stop thinking about it. 18 years passed. A forest began regrowing across the blast zone. Wildlife moved back in faster than anyone predicted. And then, in October of 2004, without warning to the public, Mount St. Helens started building again. Over roughly a year and a half, the volcano added about 80 million cubic meters of thick lava to a brand new dome, rising directly beside the one built in the 1980s. It was not violent the way 1980 had been. There was no lateral blast, no landslide, no ash falling across 11 states. It was slower and in its own way stranger to watch because the dome was rising directly through a glacier. That glacier is the one I opened with, and here is the part of this story almost nobody outside a small circle of volcanologists actually knows. After 1980, snow began accumulating inside the permanently shaded crater the blast had left behind, and it became a glacier so young that scientists had to invent a new way to talk about it because nothing like it existed anywhere else on the planet. When the 2004 dome started rising, it grew directly into that glacier and split it clean in two, physically shoving hundreds of feet of ice up and outward as the new rock forced its way through. Scientists had never observed a lava dome growing through a living glacier before. They watched it happen in real time, and what came out of that collision is still expanding today. Crater Glacier now holds more ice, by volume, than every glacier that existed on this mountain before 1980 combined. A study published in 2023 found the glacier grew by nearly 14 million cubic meters of ice in one single decade, its leading edge pushing forward by hundreds of feet. It is one of the only glaciers left on Earth that is still growing while nearly every other glacier on the planet shrinks. And it is growing on top of a mountain that killed 57 people the last time it moved. In June of 2024, the United States Geological Survey had to dismantle a monitoring station that had stood in the same spot for 18 years because the glacier had finally advanced close enough to threaten it. Now here is the part that actually brought this mountain back onto scientists' radar, and it has nothing to do with ice. Starting in the second half of 2023, seismometers around Mount St. Helens began picking up an unusual pattern of small earthquakes. It continued into early 2024, and between February and June of that year, the mountain logged nearly 350 separate quakes. On its own, that number sounds alarming, so let's be precise about what it actually means, because precision is the whole point of this channel. More than 95% of those earthquakes were smaller than magnitude 1. That is not a number you would ever feel standing on the mountain. You would not feel it standing directly above where it happened. But the United States Geological Survey does not measure a volcano by whether tourists can feel it. They measure it by what the pattern tells them about what is happening miles underground. And this particular pattern, a swarm of small, deep earthquakes clustered together over months, is the signature scientists associate with magma slowly rising and accumulating in the shallow reservoir beneath the mountain, roughly 4 to 10 kilometers below sea level. That process has an actual name in volcanology. It is called recharging. And USGS has stated plainly that the 2023 and 2024 swarms together represent the largest short-term increase in earthquake activity at this mountain since its last eruption ended in 2008. Let that sit for a second because it is worth repeating in plain language. The most dangerous volcano in the lower 48 went 16 years without a comparable spike in seismic activity. And then, twice in the space of about 18 months, it produced the busiest stretch of earthquakes scientists have logged there since the dome stopped growing. That is not nothing. And it is also not the same thing as an eruption warning, which is the distinction most coverage of this story gets wrong, and the distinction this channel exists to get right. Picture what recharging actually looks like underground, because nobody ever shows you this part. Miles beneath the summit, molten rock is easing upward out of a deeper reservoir into a shallower one, squeezing through cracks in rock that has not moved in years, and every time it forces a crack open a fraction of an inch wider, the surrounding rock groans in the form of a tiny earthquake. String enough of those tiny groans together across a few months, and you get exactly the swarm scientists logged in 2023 and again in 2024. It is the mountain's plumbing making noise, not the mountain announcing an eruption date. In a few minutes, I will walk you through exactly how scientists tell the difference between noise like this and the real thing, because that difference is the entire honest odds conversation. So, here are the honest odds, stated the way the scientists who actually monitor this mountain state them, not the way a headline would. As of the most recent notices from the Cascades Volcano Observatory, the alert level at Mount St. Helens remains at normal, unchanged, no increase, no warning. That matters more than it sounds like it should, because scientists have a very specific historical comparison sitting right there in their own records. And it is worth walking through exactly what 1980 actually looked like in the weeks before it happened, because it looked nothing like today. In March of 1980, a magnitude 4 earthquake shook the mountain, strong enough to be felt by people nearby, and within about a week, the volcano began producing actual steam explosions visible from miles away, throwing ash a few thousand feet into the air on a near daily basis. A visible, felt, escalating crisis that built for nearly 2 months before the north face finally gave way. Compare that to what has happened since 2023. Quakes so small that 95% of them could not be felt at the surface even by someone standing above them. No steam explosions, no visible change to the mountain's shape, no shift in ground deformation or gas emissions that scientists consider significant. This is not the same signature. Scientists are not describing a mountain preparing to erupt. They are describing a mountain slowly refilling a tank that emptied 16 years ago, on a timeline that, based on this volcano's own history, could just as easily take decades as it could take years. Between the 1986 dome and the 2004 dome, remember, this same mountain sat quietly recharging for 18 years before it ever showed anyone anything on the surface. Nobody wrote a headline the day that recharge started either, because nobody could see it happening until scientists went looking, which is precisely why a channel built around watching quietly instead of reacting loudly exists in the first place. So, 3 futures. And I want to be honest with you about how likely each one actually is, The most likely future, by a wide margin, is the boring one. The recharge continues at the same slow pace. Seismometers keep logging small, deep quakes that nobody outside a research station ever feels. And years from now, this exact swarm gets referenced as one more data point in a magma system that has been slowly reloading since 2008, without producing anything visible at the surface at all. Based on how often volcanic recharge signals fail to produce any eruption within a scientist's own career, this is where the smart money sits. The realistic middle future is a repeat of 2004, not a disaster. A slow, closely monitored, effusive dome-building episode, another few years of thick lava oozing up into the crater, pushing crater glacier further apart, drawing hikers to the observatory viewpoints to watch smoke rise off fresh rock through binoculars, with evacuation zones limited to the crater itself, and nothing resembling 1980 anywhere in the story. If this is the path the mountain takes, most people outside the Pacific Northwest will barely hear about it. The same way most of the country never heard about the last time it happened, even though it was genuinely historic. The honest worst case is a true repeat of May 18th, 1980, and I want to tell you plainly why scientists consider it the least likely of the three, not the most. That kind of eruption required a very specific and very visible chain of events. A bulging flank, swelling for weeks as magma pushed up underneath a section of the mountain, combined with the felt earthquakes and steam explosions that mark magma getting genuinely close to the surface. None of that is present today. No bulge, no steam plumes, no felt seismicity. If that chain ever begins on this mountain, with this monitoring network sitting on top of it, it would very likely be one of the most closely tracked volcanic buildups in American history. And residents downstream would have far more warning than anyone got in 1980, when the entire monitoring network amounted to a handful of scientists with radios and a handful of seismometers strung together with far less coverage than a single county sheriff's department runs today. That gap between then and now is the actual safety story here, quietly more important than any single earthquake count. Here is my honest opinion, after everything the research actually shows. I don't think Mount St. Helens is hiding anything from us. I think it is doing exactly what a young, still settling volcanic system does, refilling itself in full view of some of the best monitoring equipment on the planet. And the reason this story feels new to almost everyone watching is not that the mountain changed. It is that the story stopped getting told the moment the news cameras left in 1980. The eruption made this mountain famous for one morning. The glacier, the recharge, the entire monitoring network built in David Johnston's memory, none of that ever got the same coverage, because a mountain slowly refilling a magma chamber does not make for good breaking news. It only makes for a good documentary, which is exactly what this channel exists to be. This channel exists because the ground underneath this country never actually goes quiet. It just stops making headlines. I want to ask you something, and I would love to read your answer in the comments. If you were alive on May 18th, 1980, tell me exactly where you were and how you first heard the news, because I have read hundreds of these stories from viewers on this channel, and every single one is different. And here's the honest question underneath that one. Before this video, did you assume, like almost everyone does, that this mountain story already had its ending? I want to know if I changed your mind, or if you already knew about the ice. If this video actually taught you something you did not know about a mountain you thought you already understood, do me a favor and hit the like button, because it is genuinely the only way this channel gets shown to anyone else who grew up watching the same news coverage you did. And subscribe, because next time I am taking you to a slope in Alaska that geologists are already watching move a little more every single day, on the side of a fjord where people still live, still fish, and still have no idea what happens if that slope ever decides to let go all at once. The ground beneath America is speaking. Make sure you are listening.